I'm posting this video in response to a couple questions on some of the basics that we covered yesterday and how I see those kind of causing some simple errors today. So even though I think the videos and information I posted yesterday should have brought everybody up to speed on a lot of this, I'm going to work through a couple of these sample problems from your homework today here in this video. So if you're watching this video, here you go. Here's a couple freebies for your homework. If you already did them, well, good job, and you can go ahead and check your work. So for basics, for starters here, we're going to be looking at this chart right here. This is an XY chart, a number line, a coordinate system. This is just your reference point to give you a visual aid on what a vector looks like. So in the context of what we have here, I just have 10 as your scale. So that's the maximum values on this chart here. And that is really irrelevant. The scale could be whatever you want it to be. You could take this all the way out here to 20. You could draw your own scale on your own XY chart and say that every value is 2 or every value is 10. None of these drawings are to scale. They're just visual aids so you can draw your vector, and we're going to need this for the next step when we're solving for the direction. So don't get intimidated if something doesn't land on your chart and you have to rescale it, or if you want to do it on your own graph paper, all that's fine. Now let's look at our letters here. So in the directions, we talked about all the vectors being from the origin. And by vectors, I mean these letters here, B and C. These represent vectors. Now, these numbers here are the coordinates of those vectors, and the directions said that all these vectors originate at 0, 0. So their point of origin is 0, 0. So don't get those numbers mixed up. If they give you the letter here for the coordinate, one of them is y or x, they're not talking about the plane. All they're talking about is that's the name they gave the vector. So that's just the label they gave it. All right. So we have B and we have C. Now, this value here is the x, and this value here is the y. It's always like that. You're going to see it like this written a lot of times. The x is on the left, the y is on the right. There's a comma in the middle separating them. That's just kind of the standard nomenclature for when people are writing coordinates. So it's not going to tell you x equals 7, y equals 9. This is just the implied values based on math. And the videos yesterday I posted, they should have cleared that up for you. But either way, if you're watching it now, that should clear it up as well. Now, when we add these together, which will be the next step after we graph them, we can't add x to y. That doesn't make any sense. And we can't add it to the y and the other vector. X's add to x's and y's add to y's. We can only add like terms, so it's kind of like your units. If you have inches, you can't add that to feet. If you have meters, you can't add that to millimeters. You got to make sure they're the same units. That's the same idea here. So if we're going to add these together, we're adding the 7 to the 9, both the x's together, and the 9 to the 4. And I picked these ones because they have some negative values, so don't forget any of the rules we learned in basic math on how to handle negative values. So for starters, let's go ahead and just graph B. So I'm going to come over here to my point of origin, which is 0, and I'm going to say, okay, I'm going to come over 7, and then I'm going to go down -9. So remember, the negative values are down, and the positive values are up. So I'm going to come down -9, and that's going to be my first vector. So I'm going to draw a line from the origin to the coordinate, and I'm going to call that B. Now for C, we have 9 and -4. So the x value is 9, so I'm going to come over to 9, and I'm going to go -4, so I'm going to go down 4. So here's my coordinate. So I'm going to have another vector traveling to there, and that's going to be C. So I'm going to clean this up a little bit, and then we'll look at what exactly that tells us. So in this case, you're adding two vectors together. So you're heading in a direction for B and C, and since they're both going to add together and they're both in the same direction, they're actually going to be increasing the magnitude because their magnitudes are in line. If we had one heading in one direction, like we saw in a reading the other day, and one heading in another direction, they're going to cancel out some of each other, and you're going to wind up with a smaller value. When they're all heading in the same direction, it's kind of like putting a bunch of batteries in series with each other. You're going to increase the output. So I can already see here that this is going to be kind of off this pre-printed chart for you guys. Feel free to rescale or draw things wherever you need to so you can solve your problems. These XY charts were just so you guys aren't drawing it in by hand, but don't get intimidated if it doesn't land on there like we talked about. So I'm going to take my 7, -9, and my 9, -4, and I'm going to add these together. So 7 and 9, I'm going to get 16, -9, -4. A negative plus a negative is just subtraction, so I'm going to get a total of -13. So this is my new vector when I add those coordinates together, which is how you add vectors together. So I'm going to be off my imaginary line on here on the x-axis over to, I'll just call this 16, and then I'm going to come down to 13 and say, okay, here's my new vector, my resultant vector. So that's vector CB there, or C plus B if you want to call it that. So all I did was add these coordinates together, keeping like terms, x plus x and y plus y, and getting this total. And then all I did was graph the new one. Now we'll see in a couple of the other examples I'll post that vectors in opposite directions are going to cancel out, and vectors that are in the same direction are going to increase.